Iter in Python is used to loop through collections in a way different from regular loops. Since programmers are never very creative, the iter function creates an iterator over a collection. In this example, we are creating an iterator called it over the list of numbers called nums. An iterator is an it because it is just an object that knows two things: where it's at in the collection it's looping over, and what the next element it's going to is. You make the iterator go to the next element by calling the next function on it. Calling the next function will return the element the iterator went to and update its internal state to the new next element it needs to go to. So if you call the next function on this it in the example, it will return 1 and then know that the next element it has to go to is 2. If you're a psychic, you probably see the badness that we're quickly approaching. After we've called the next function 3 times, the third call will return 3, but what element will the iterator try to go to next if we call next again? There's nowhere else for it to go. Python sees what you're saying, and it doesn't try anything stupid. If you call the next function on the iterator one more time, it raises a stop iteration exception. So if you wanted to solve the classic problem of looping through a list and printing every element, this is what the code would look like. You might say, this is an incredibly stupid way to just loop through a list and print out the elements. And I would agree with you for this case, but let's change the problem we're solving a little bit. Let's change this list of numbers to a set, and say we want to remove all the even numbers from the set. Classic Python loops will disappoint you, as you'll get a runtime error that the set changed size during iteration. But you can solve this problem with iterators. The moment Python gives you an error for trying to solve this problem is when you've removed an element from the set, then try to go to the next element. If you simply make a new iterator after each time you've removed an element from the set, you never trigger the runtime error from before, and you can technically modify the set while looping over it. This is not wasting memory to make a new iterator each time you remove an element, because the alternative would be making a totally new copy of this set. So by comparison, a new iterator uses a much smaller amount of memory. Like and subscribe to learn more.